Welcome back to MECH 1350. We just wrapped up Labs 15 and Lab 16. We're in Chapter 12 doing branching instructions, things along those lines. Alright, we're going to step into the next part so we can complete some of the rest of the labs here. We're going to go through using register instructions. Alright, so we can do arithmetic registers to store numbers. Remember, registers are global, which means I can use them in any program that I want, whatever register I've recorded with whatever data I've put in there for its user, I/O. Alright, so we can use numbers for doing arithmetic operations, so we want to do counters or things like that, so we can count up, count down, do that sort of thing, and store it into a register, as we do a certain number of loops, right? As we do a certain number of loops, we can store how many times we've done that loop, and get into that sort of thing. We can use I/O data, and we can use default registers and things like that. All right, so the default number of registers is 200. We can do that we can change that during the initial setup with a controlled start. Okay. So when we go through this, all right, let's start talking about the data registers now. You're familiar with position registers, right? We made our safe, or our home, and our maintenance, or our repair positions using our PR. Data registers, we're going to use them, but they don't store coordinates. Remember, position registers only store coordinates. Data registers store data. Okay, so we use them for indirect addressing, like I was just talking about, using it to count as we go through something. So what we want to do is, if we have this example of code right here, we have these 7 lines of code. All right, and on the right hand side, those are registers. So remember, that's a separate screen under the data button on your teach pendant. So it looks like we can run split screen, all right, on the teach pendant as well under our view command. But if we take a look at this, on the left hand side we have our program, all right, and on the right hand side we have our registers. So if we take a look, we look at line 7 in the program. Okay, it's going to move to position register 5. Okay, so PR5. But it doesn't say PR5 in the code, right? It says position register 10. Now, if we look on the right hand side, what's scored, or not scored, sorry about that, what's stored in register 10 is the number 5. So if we look at register 10 on the right hand side there, what's stored in there? Number 5. So that's kind of how that program works. We can use a PR, all right, and what's stored, so we can go to PR5 if we have a specific number. If we look even at how it works and where it pulls in from, it doesn't have to be a set defined PR. Hopefully that's kind of like makes sense to you. I can say PR1 home, or I can say PR register 10, and we got to go back and we got to say what's in register 10. Okay, so what's good about this is how our robots can interact with PLCs and things like that. So very, very, very important here. Now, we're going to talk about direct and indirect addressing. So if we look at direct addressing, that's where we put the specific data in that we want. Register 3 will be 8. Okay, that's what we see on the left hand side. On the right hand side, we are going to get register R3 is 13, okay, and then we have R8 is 13. Okay, so we can indirectly do that. So we're doing 2 things at once. We're using what's on the left hand side. We're saying that register 3 is equal to 8. Then indirectly on the right hand side, we know that register 3 is 8. So we're taking the register of register 3, which is 8. So we're saying that register 8 is now equal to 13. So we're indirectly going back and forth between those two. Okay, so let's take a look here. Registers, right? We said we could change it, but initially we're going to have 1 to 200 for direct, and then you can also use indirect, and it was we just talked about. Now we can use different values here. We can use AI, AO, so analog in, analog out. We can use a constant value. Okay, we can do GI, which is general input, and GO, which is general output. We can use DI, digital input, and DO, digital output, so on and so forth. Okay, so we can use, RI, RO, SI, SO. Okay, user input, user output. Okay, work overflow, output, register input, register output. All those different things that we can go through and store data in here. So we can use this to do different counting. Okay, so example would be if we have down below register 1 is equal to register 1 plus 1. So we're going to take register 1 and increment it by 1 and store it back into register 1. So every time we would do a loop in the program, we would increment register 1 by 1 value. So if register 1, started out at 0 and we looped it through, the next time around it would be a 1. Then we loop it through, the next time it would be around a 2, around a 3, so on and so forth. Alright, so we have different limitations that we can do in how we can do math operations here. We can mix addition and subtraction in the same instruction. Okay, but you cannot mix multiplication or division in the same instruction that already contains addition and subtraction. So, kind of maybe think of order of operations and break them out. Addition and subtraction go together so that they can be in the same line of instruction. We cannot include multiplication or division in that instruction. That's really what that means. And then oppositely, right, we can say that multiplication and division go together in the same instructions, but we cannot mix multiplication and division with addition and subtraction. Okay, so multiplication and division together, addition and subtraction together, but not crossing those boundaries. No addition with multiplication or division, and no subtraction with multiplication or division, and vice versa. Okay? So, the maximum number of arithmetic operations we can have in one instruction is 5. Alright? Now, the programs only read the lines of instruction once unless you loop them. So you got to remember to make sure that you use a loop. Alright, if we want to use an if instruction, alright, if register 1 is equal to this value, a constant of 10, we will either do some sort of action, jump label, or call out a program. So does that make sense? We'll kind of go through it. So if this is just a mock program, so we can say if register 5 is equal to 2, we're going to call out program, circle, something along those lines. So we have our operators. We can say equal. Okay, we can use not equal to by using the open and closed inequalities facing each other. We can use less than. We can use less than or equal to. Okay, greater than or equal to. We can say that it's equal to a constant value or another register value that's a constant value. And what can we do from that? We can jump label, so we can jump to somewhere else in the program, or we can call a program. So this is kind of how our if instructions are going to work if we're using some sort of operator. So for a couple of the mechanics that we have on carts, we're going to say if digital input is this, because I'm going to push a button on the cart, alright, and it's going to make the robot do one of your programs. So we can say if, and we have all these choices for our if our digital output, the DO, or if our digital input, or robot output, or robot input, okay, string input, string output. If we use any one of those, okay, and then we have our operator is equal to whatever value we want, on, off, a digital input, a digital output, a robot input, and we can call a program too. So look at the bottom. The bottom line says if digital input 1 is on and digital input 2 is off, we're going to jump to label 2. That's really how that's all we're doing there. We have our if statement. Okay, if what? Our digital input is a 1 and it's on, then we can link it together with an AND statement and digital input, or you could write 2 if statements, you would say, and it would kind of go through, but you don't want to write it as 2 if statements, you want to write it as all one operation, and then we'll jump to label 2. Let's see here. Okay, now we want to be able to loop something. Now I know if we take certain programming classes like C++, things like that, you don't want to necessarily get stuck in an infinite loop. This program's not an infinite loop. This program is going to loop for a certain amount of time. So make sure that you pay close attention to this, because you're going to write a program with your robot, or you're not going to write a new program. You're going to use one of your existing programs. So you're going to use circle, triangle, or square, and you're going to draw a triangle like 5 times and then end, or you're going to draw a circle 5 times and then end, so on and so forth. So this is how we create a looping program, and this is how we do a specified number of loops for it. Because normally if we just had label, jump label, a few lines of the code, it's just going to sit there and cycle through everything. But we can use registers as a type of counter and use that counter to control how many times we go through the program. So let's go through this line by line. This is called a for do loop. So think of it as like, for this amount of time, we're going to do this stuff. So think about it that kind of in that aspect. So we're going to define register 1 and register 2. So when we say register 1 is equal to 5, we are storing the value of 5 into register 1. When we say register 2 is equal to 0, we're storing the value of 0 into register 2. So make sure you know registers are global. And then once we store those in, all right, we're going to put the label there so the program can jump to there. We don't want the label above the registers, because what's going to happen is no matter what we do and tell the register to increment, it's always going to reset them as 5 and 0 if we have the label above them. So that's why we have to define the 2 registers for the first 2 steps of the program and then have the label after that. So as we go through our incrementing of registers, it'll jump back to the label and not back to the beginning of the program and rewrite the registers. So what it's going to do, this is going to do the box program here. So we set register 1, set register 2, we're going to have our label 1, and then we make our points. So we're going to make our box, so that would be point 1, point 2, point 3, point 4, so lines 4, 5, and 6. Then what do? We take register 2, and we increment it by 1. So since it started at 0, we're going to increment it by 1. Register 2 on line 8 after it completes line 8, will have a value of 1 in it. So what do we want to do? We want to control it. We want to control, it says in line 9, if register 2 is greater than or equal to register 1, we're going to jump to label 2. Okay, so reread that. If register 2 is less than or equal to register 1. I think I said that incorrectly the first time, so I want to restate that. If register 2, I'm on line 9, if register 2 is less than or equal to R1, we're going to jump to label 2. We just made register equal to 1. It's less than R1 because R1 is equal to 5. So register 1 is less than 5. We're going to jump to label 2. Okay? And then it would what? Exit. I misspoke on that. Let's walk back through this again. All right, starting from the beginning, we've defined register 1, register 2. I messed up the less than or equal to, and I want to make sure we get this straight. So this does say what I said the first time. On line 9, if register 2 is greater than or equal to register 1, then we will jump to label 2. Jump to label 2 means we're going to exit out the program and be done. But if register 2 is less than or equal to register 1, okay, we're going to go to line 10 and jump to label 1, and we're going to do like the box program again. and then we do the box program, and then we increment register 2, and we go so on and so forth. So as long as register 2 is less than or equal to register 1, we're going to keep doing this program. And we've set register 1 to 5 times. So this means we're going to loop this program 5 times through, and then when line 9, when register 2 equals register 1, we're going to jump to label 2 and stop working. So you're going to do a lab on this. Okay? Here's another way of writing the same type of program. So instead of incrementing, we're going to decrement. So we're going to decrease a register. So you might like this method better. We're going to define register 1 as 5. Okay? And then we're going to have our jump label. We're going to draw our box. And now what we're going to do is we're going to take register 1. We're going to decrement it by 1. Okay, so we're going to take register 1, it starts at 5. Once we do a box, we're going to subtract it down to 4. We're going to do the box again, subtract it down to 3. We're going to do the box again, subtract it down to 2, all the way down to 0. All right, so if R1 is less than or equal to 0, okay, we're going to jump to label 2. So when it gets to 0, it's going to jump to label 2. We can see label 2 is line 10, ends the program. But as long as register 1 is greater than 0, we will keep doing line 9 and jumping to label 1 and keep drawing the box. So this is a different way of doing the same looping type program that you're going to do. But you're going to do this with your circle program, your box program, or your triangle program, all right, as we go through this in the lab. This is called a while loop. Okay? So remember, these ones before are called the for do loops. This is a while loop. Okay? So what this does is it creates a loop that executes until a specific condition is or is not satisfied. So notice we're not defining any registers here. So what we're doing is we have label 1, which is what it's going to jump up to. It says if digital input 1 is off, we jump to label 2 and we would end the program. However, though, if digital label is 1, okay, if it's not off, we're going to keep drawing this box. All right, so we're going to go da-dink, 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 our 4 points. We're going to go down, jump label 1. We're going to go up to label 1. Then we're going to check, is digital input off? Nope, it's on. We're going to keep going, draw the box again, and go back and forth. So this will not change until the digital input is switched to off. So as long as the digital input is on, we're going to keep drawing this box. And it's going to jump to the beginning of the program and redo it over and over and over. Once digital input 1 becomes off, we turn the button off or whatnot, it goes to jump label 2 and turns off. So the for do loop that we did before, you know, it was using a counter. So we defined the number of loops that it did. This is not defining the number of loops we do. This is being driven by an input. So as long as the input is on, we're going to be doing this loop, drawing this box. The second the input comes off, all right, we stop drawing the box. So we may have to draw it 10 times, we may have to draw it 20 times, we may have to draw it 2 times. That's what it would be doing. Okay, we can use a repeat loop. Okay, so in this case, label 1, draw our box. Then if our digital input is on, we would exit. If our digital input is not on, okay, we would just keep drawing the box, going from jump label 1 up to label 1, redraw the box, okay, as long as our digital input was off. So similar to kind of the last program, but just different ways of writing looping programs. You know, if you needed to do a task, you know, multiple times as it goes through here. Okay, this one is a little confusing for some people when you guys use the select command. When you are doing your programming, there are multiple select commands that you can choose from. You need to make sure, or call me over and ask me when you do your select. All right, so we're going to select a specific register, okay, and then we're going to have, if the register has this value, we're going to do this. If it has this value, we're going to do this other thing. All right, and then if it has this value or else, it'll do this. So example here. All right, we're going to say if register 1 is equal to 1, our action would be call your circle program. Contrary, on the next statement, if register 1 was equal to 2, we would call your triangle program. And if register 1 was equal to 3, we would call your circle program. Hopefully I used box, triangle, and circle in that order. And that's what we're going to do. So based on the input, this is how we can use a PLC to drive something. If we change the value of the register, the robot will know, oh, I got to pick up this. So a good example is on station 5 on our 870 trainer. It needs to know, the robot's got to know, do I pick up the plastic valve body or do I pick up the metal valve body? It doesn't know that it's plastic or metal, but based on the input or output from the PLC that a plastic valve body has gone over, the robot knows that, oh, I got to execute this program because the valve body's over here. Or, right, if it's metal and the PLC sends it a 2, all right, it's metal. Oh, the robot's got to go over to this different location to pick up the metal valve body. So that's kind of where it comes into play. And this is how we're going to write our program. Okay, so you would do this in one of your labs. You're going to have label 4 here. Why label 4? It's so that it's going to constantly go through this program, checking register 1 to see if there's a 1, 2, or 3. If there's not a 1, 2, or 3 in register 1, it's going to go back to label 4 and then keep checking for the value in register 1 to be a 1, 2, or 3. That's really all this is doing. This is so that you can walk away from the machine and it's going to run in auto. So as soon as register 1 has a value in it that it's a 1, 2, or a 3, it's going to run the specified program. So for you guys in class, all right, I'm going to have you, we're going to use like register, I'll forget which one I'm going to tell you, but we might use like register 5, okay? If register 5 is a 1, you're going to call your circle program. If register 5 is a 2, you're going to call your triangle program. If register 5 is a 3, okay, you're going to call your box program. If it's none of those, it's just going to keep cycling. And you can watch, we'll hit the data button and we'll change the value in the register and then you'll see the robot, oh, I've got this program. Okay, so it's very cool. A lot of good interaction with the robot on that. But that's the key value right there. Okay, what value is being changed in the register? So this is really cool about the select command. So we're going to select the specific register and then we're going to define what values, if it's this value, do this. If it's another value, do this. All right, and call out different programs based on the values of the registers. Okay. Then the wait instruction. We do need to use this when we're doing our looping program. If we don't wait, the PLC is faster than the robot. Our program actually won't work. So you're going to have to put a wait interval in there or it'll read it too fast. All right. So the whole point of the wait instruction is to delay the program execution until the specific conditions are true. So the previous program, so like this one I show you, if we don't have a wait command in here, it may not be able to pick up the change in the register in time. So we want to wait before it jumps back to label 4 so that there's time for the register value to change. All right, so we want to be able to change the time value so it doesn't have to be much. It can be like 0.001 or something along those lines. We do have to change the amount of time that it waits. Okay, so what we can do is we can use different instructions here. So we can say wait, register 1 equals a constant value, and we can say forever or timeout, do those sort of things. So you can read through this piece in the lab, but we'll go through it in the lab. So we can have it do and conditions. This and this have to be met before we do this. All right, and we can do a timeout, so it'll constantly check. Oh, it's been too long. I'm going to time out. We can use an or command, so this condition or this condition has to be met. So like if we need like 2 buttons pushed, right? This button and this button to execute. So like, you see in the movies where they have to launch like a nuclear weapon. They have to have this key and this key. It's not a this key or this key. This key and this key turn and the button has to be hit kind of scenario. So just think of the different logic that we've talked about in digital electronics and things like that when we're talking about the and the or instructions. All right, we can do payload instructions. Not going to get too much into this just because we're not doing a lot of payload on the end of our tooling, and as well it's going to kind of depend on your different robots that you're working with in industry. We have our large robot or we got our little robots. Our payload weight's a lot different on the different robots that we have in class. So but it's based on the weight, the center of gravity, moments of inertia, where things can flip and overpower the servos and things like that. So just different things to think about. But like I said, we're not going to get too much into payload, but you can restrict the payload and things like that on the motion performance here. But we're not going to do, like I said, anything with the payload labs because we don't have a lot of labs to go through and a lot of different payloads that we're going to pay attention to. Okay, so these are the 3 labs that you're going to do. You're going to do labs 17, 18, and 19. They are located at the end of chapter 12. We're getting closer to the end here, doing good stuff. All right, hopefully you guys will get your certs here soon. We still have a few labs after this. But we're going to do lab 17, so you're going to call programs using an if and select instruction. You're going to use register instructions, okay, and I'll define what registers I want you guys to use so you don't overwrite any that are on the system for other programs we're doing. All right, and then we're going to call out programs, and then I'm going to have you guys write something on the big robot and learn to use that call out real simple because I've had them set up the other robot so that we strictly only did call outs just so that you have to do this, and it'll execute the programs based on what you tell it in call out. All right, as usual, guys, if you have any questions, please don't hesitate to ask in class. All right, else I will see you in lab, and I will be there to guide you and help you with whatever questions you may have as you're programming your robot.